Example 16.14 gives us another rational function to sketch the graph of. Here we have h of x equals x minus 4 over x squared minus 16. Let's factor the denominator into x minus 4 times x plus 4, and I'm going to use that to write the domain. The domain of h is going to be negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. So there are two discontinuities in this function, and I need to test out each one of them. So let's start with negative 4. So h of negative 4, that's going to end up getting me negative 8 over 0. So that is undefined. That would imply that there is a vertical asymptote located at x equals negative 4. Then I'm going to test out positive 4, h of 4, and that is going to give us 0 over 0. That implies that there is going to be a hole located at 4 comma something. So let's go back to h of x, and let's go ahead and cancel out the x minus 4 common factors to write down 1 over x plus 4. Then I can reevaluate. H of 4 would then be evaluated to be 1 over 8. So I know the exact location of the hole. It's going to be at 4 comma 1/8. Now let's talk about the horizontal asymptote. This is a bottom-heavy function, and with it being bottom-heavy, the horizontal asymptote is always going to be y equals 0. For your x-intercept calculation, we will be expected to take h of x and let it be equal to 0. It is important that when you do your x-intercept calculation for one of these type rational functions, that you use the simplified version of the equation. So we're going to use 1 over x plus 4 and set that equal to 0. So when I do that, I then multiply both sides by x plus 4, which cancels the x plus 4 on the right. On the left, it's just going to say 0, but it's going to say 0 equals 1, which most definitely is false. So with that being false, this means that there is going to be no x-intercepts. And that may seem like it's a bum deal here, not getting any x-intercepts, but not having x-intercepts can actually be just as important of information as having x-intercepts. So we will use that to our advantage. The y-intercept calculation should again be used with the simplified version of h of x. So you're going to be calculating h of 0 to be 1 over 0 plus 4, which is just going to be 1/4. So there is a y-intercept located at 0 comma 1/4. Let's put this information on the graph, see what we have. Starting with the y-intercept, there is no x-intercepts. There is a hole, however, and I will represent that hole with an open circle at 4 comma 1/8. So you do the best you can, estimate about where it's located. And then there is going to be a vertical asymptote located at x equals negative 4. So as far as the table is concerned, I do understand that our domain is written in 3 intervals. However, the second and third interval are separated by a hole. So it's actually going to be more convenient to think of the second and third interval together with that hole connecting them. So we're only going to do 2 tables on this. We're going to do one table for the negative infinity to negative 4, interval, and then we'll do another one for the -4 all the way to infinity, so everything to the right of the vertical asymptote. Let's start with the left side. With the left side, I'm going to be interested in plugging in -6 as well as plugging in -5. When I plug in -6, I get -1/2, plug in -5, and I get -1. So we'll plot these 2 points. And I missed something. I missed the horizontal asymptote. So let me go ahead and put that in here as well. That's going to be at y = 0. And now I can see that these 2 points are really close to the horizontal and vertical asymptote already. So that means that we can probably get away without needing a third point. I'll connect these together, going toward -infinity on the vertical asymptote, and then trying to flatten out here as we get toward the horizontal asymptote on the left. So that's the first piece. The second and third piece, as I said, we're going to look at these together. And I already have a point in a hole. What I would really like is another point closer to that vertical asymptote. So I'm going to pick -3, and then I'd like a point further to the right, so I'm going to pick 6. -3 is going to map to 1, +6 is going to map to 1/10. So let's mark the point at -3, 1, another point at 6, 1/10, get that close there. And if you've paid attention to the y values at each of the points and including the hole, these are all decreasing. So there should be a nice curve here where it's going to be decreasing, and it's just going to naturally flatten out as we head toward the horizontal asymptote. And then going back here to the left, I would have one of 2 options. I'm either going to curve down, or it's just going to continue on its trend, and it's going to end up going up. Now, we said that we didn't have any x-intercepts. So if there's no x-intercepts, then it's not going to be possible to have the version where it goes down. So it's going to have to approach +infinity on the right side of that vertical asymptote, and then this gets us the complete graph for h.